My name is Søren. Welcome to D3P. You probably ended here on this channel mainly because you own a 3D printer and maybe also because we want to look into a kind of beginner's way on construct some things, not to make it too complex, but find a good solution. Many of us that have a 3D printer use it for print beautiful vases in all kinds. It can be more scary things like a skull as a container, or a nice cat, and you can find tons of this in Thingiverse, My Mini Factory, and so on. There are many other pages for that. Then maybe later on you try to print more practical things, and in this case I made by myself for my old ANET a blower, and I call it the Bigfoot. And later on, this is simple things that helps me in daily life, and this is for my Ender 4, and when you have to install the bed level sensor in the beginning, you can use this, and it's mostly pre-configured by doing that. All this one where I have designed this to get put on a wall and enter my studio lamps on it, either in the roof or on the wall or whatever, so I can change the way the light is in my printing studio. Or you maybe start to produce gears, and there are several places where you have gear calculators and produce beautiful gears and put them together so they have a function to do. So all in all, you probably will get more and more interested in 3D printing, and that was also how I started. But with the time, I also started to find out that, hey, there are some things in my home or in my garage or whatever, a kind of a tool or some practical holders, any kind that I could design by myself. And there is one very simple tool to use, and they are free. This is on Thingiverse, and you just register and you can use the tool. But also Autodesk 123 Design is really a great program. I don't think it's supported anymore. It's more or less out, and it's been replaced by Fusion 360D, but I'm not a student anymore, so I can't use it. And well, I think the monthly fee is absolutely too high for what I construct in daily life. There's also a free open source program called, I think it's Onshape. I started to look a little bit on it, but it's also much more advanced, that builds up 3D drawings and convert them to STL files, mainly through doing sketches. But I will have focus today on 123D design, and I want to design one thing, because my house in Thailand, when they built this house and they put the pipes in the ground, and you can see it on a picture here, they did it wrong, and they also cut them after the floor was on too low, and this makes that I couldn't find anything at the stores to cover here and let the pipes from the wash go down. And this pipe is also connected to the septic tank, so the smell can be quite bad, especially in the heat. So the reason I couldn't find something to put on the top here, I think I have 3D printers, so why do I not start making my own solutions? And that we will do today, and we will, first of all, we will measure this, make a small drawing, and then we will go to the computer and construct our thing, print it, and see if it fits here. And next time I go to Thailand, I will, and that's in December, I will take the parts with me and repair the floor in my house. So let's start construct this thing. So the first thing we need to do is to make a small paper drawing of what we want to do, and especially to get the measures on the pipe we want to do some modifications on. So let me start with doing some few circles here. Damaged. Would still work. So it doesn't need to be perfect. And just put a line in here. There we go. And this should be, this is my how should I say, the holes that on the flange that will fit into the pipe. Okay, so this is the inner circle. And then I wanted to be a little bit outside, so it moves into the tiles, and this will be something like that. And I want really it to be 20 millimeters from the inside and out. This will give me a nicer look on the floor. My floor is black, so I want to do this in a black, nice black color. Another thing, I need to measure this here. I don't like to use a ruler for that. I never get it totally precise, but you can use a caliber as well. And it says, turn it on. It's broken, this pipe. It's 108, it's 109. So I say here to there we have 108.5 millimeters. Then I have the pipe from the boss who goes into this is 40 millimeters. And I don't want that in the center. I want this exactly a radius down, and 40 millimeters, it would look like that. And this would be 40 millimeters. Why that? Because I have 3 toilets in my house in Thailand, and they made a mistake on all 3 toilets. In this case, I can just screw the plate around before I glue it with silicone, so it fits exactly to the pipe from the wash. The pipe is a flexible pipe from the wash, so it just goes in here, and we use silicone to get it tight, and the same we will do silicone inside here before we lock it as well, so it will be tight and I don't get scorpions into the bathroom from the septic tank. So this is the small drawing we just made, and let's go to the computer and make a construction of our thing that we want to print. So we are now in Autodesk 1.2 3D Design, and it is in this tool here we want to design our flange for the pipe in Thailand. Basically, you can also use sketches here. I don't want to go into this because 1.2 3D Design also have very easily primitives here. In this case, our thing is basically only cylinders, and that's what we will use here, but you can combine all these shapes and you can modify all these shapes later on. But let me start with a cylinder, because as you can see at the top left, we need a shape that is 141 millimeters. Well, I will do it 140. So I click on it and I place it here. When I now click on this, I get a new menu here, and here I can, what I call it, small scale. And if I do this 140 millimeters by 140, oh, here, sorry, 140 here, makes a circle. Right now you have an oval. And the height of it, well, I think this, if I make this, if I remember right, I make it 5 millimeters thick. So this is my circle we constructed. This is the outer shape. And well, let's start to make the flanks then. First of all, I confirm my shape. I mark it. I put the D on the keyboard just so I get it down on the bed. So for the flanks, I also need a circle, or sorry, a cylinder, and I will put it here. This one I will want to give another color, so I just can see the difference from it. And I make it a nice red here. And this one I want to build, it should be from here to there, 10 millimeters. So I add this, and I will show you why. We made this 5 millimeters, so I want to do the high to 15 millimeters. So then I want to have the outer line here, and it comes up as standard with 20. And what we said was the pipe was 108.5. So I think I will make it 107. And I'm sure it fits, and I'm also sure it fits when it comes down to the pipe, and I will use silicone for tighten it. So this is my first circle, and in this case now I want to duplicate it, or make a duplicate it, make a copy of it, and I use a Control C and I use a Control V, and you get these arrows here. And as you can see now, it is exactly the same shape as this one. So I will give it another color again and make it a green. This one I need to modify now, because I want 5 millimeters, a wall of 5 millimeters here. And that's why I need to wait. Here we go. So this would be, that was wrong. I'll try again, this one. So if I take 5, that means 10, it would be 97. 97 and 97 here. And I will make it a little bit higher, maybe just 20, because this will be removed from this part later on, and this we will do right now. Just zoom out. This one I really want to move away over here. So now you see I have these two shapes, and I want a hole inside here. This is quite easy. I mark both of these shapes and use an align tool. There we go. And you see you get some dots, and this will center both parts. I will do that now. I will center this way, and I will center here. This means that they are totally aligned with each other. And I want to keep the red one, and the green I want to make as a whole. There are two ways to doing this. One is you can extrude the green away, or you can do just with the combine tool, I can subtract. And I start with the target, that is my solid mesh. It's a red one, and that I want to keep, but I want to remove this mesh, the green one. So I mark this as a number second and push the enter button. And as you can see here now, we have a beautiful flange. So I want this to be combined on this one, on the blue one now. So it's the same procedure. We go in and we align everything smooth and nicely. There's only one thing that I will do different here, and that is, this is, I wanted not to be like this as we did on the other one, but I just want it to be plain here at the bottom. So now it is solid there, and it's opened here, and this part here will go from there to there, will go down to in the blue pipe with silicone on. So now I have put these two things together. There are two ways you can do. I want to combine this now, and one of them is I can group them. You also have the possibility to combine them, but if you combine them, you cannot ungroup them later on if you want to make modifications. So I would recommend to group them, and that I have done here now. This means when I select this one, I move everything. Again, I want to push D, so I get it down. Now, as the third thing is, I need, matter of fact, a cylinder again. And this time, this will represent the hole for the pipe from the boss. And as I said, the pipes down there are flexible hoses. So what I know is it is 40 millimeters, so I will do this 41 and 41. I can let it be 20 because in this case now I will extrude it, but first I align it to the rest, to the absolutely center. So, and now I can extrude this one, and I will use this one and this one, because now we are totally in the center. And you see you get this arrow, and with the left mouse button I just push it down now. Click on the outside. And as you remember, we didn't want it like that, so I just unmark it, because what I really wanted is I wanted a radius from the center, and that I can do by using the move tool. And this is this one, and I can take the arrow and I can move it. It would be moved by 20 centimeters or something like that. There. This is where I want it, and now I can extrude this one out of the thing. So it looks like that now, the whole way around. And well, I want to grade the corners here a little bit, and especially here, because I want to put it into the pipe, and I want to be sure I can get it in. So, but we have this tool here, and you see you can make a fillet that's a rounded edge, or you can do just a flat edge, and that's what I want to do here. And I mark it, and you can use the arrow to move up and down. You see now here it's changed the shape. It's too much for me, but I will maybe do one millimeter. So the same I want to do here on this one. Let me do the same here. Use 1 millimeter. And here we go. So we made a nice smooth edge there. And I also want to do that maybe only a half. No, I don't think on this side. I think it's okay, but here I want to do it, this one. And that we will do right here. And I mark this one and give it maybe 0.5. So, matter of fact, we have constructed our, let me move this away, we have constructed our flange for the pipe that we not could buy any place. It doesn't exist, matter of fact, and this will be totally tight so I don't get any smell from the septic tank into the bathroom and, for instance, in the rest of the house, because it will be 100% tight. And from the wash and down to the thing, there's a water log in between, so there it will not come through. Well, now we have to, I always put it to the bed by pushing this. And because we group this thing, I cannot just export it in once to an STL file, but I can choose here, combine the objects. I want to find mesh settings and combine the objects, and I print just OK. And I will move it to my library, and I will call it the thing. So here we go. We have now put it to my drawer. The next is going into your slicer. I will use Simplify 3D, and let's take this away. I will import a new one. It's the thing, and I just correct this so it gets into the view. So this was my Dremel. I want to print it on my Ender 4, and the layer height here is 0.2. I think I need to use 4 bottom layers, 4 top layers. I want it really to be watertight. The infill, in my case, it doesn't really need, no one will walk on it, so it will be a pure lock, but I will still give it 25%, and maybe that's not enough, but again, I want it to be quite tight, so there's no smell coming up. Skirt, I always use a skirt to clean the nozzle. Infill, grit, support, no, we don't need any support here. It's a flat product. This is, matter of fact, important when you design more complex structures, and it is how you design it and what way you turn it around, so the print can be faster. You maybe need less support, and in this case also save materials. So the filament I will use is a black filament, and I know from before it works very well at 200 degrees. Maybe I will print this thing quite fast because it's quite big, so I will give it a little bit more heat, and in this case it will be 205. Cooling, well, it's my Ender 4, so it's always on. In the script I don't do anything. Speed 50 millimeters per second. I think it sounds good. The rest should be right as it is. So let's update it. Looks like this. Yeah, looks quite good. Beautiful thing we've just constructed. And let's see how long time it will take to print on the Ender 4. And it takes 4 hours and 25 minutes. I will use 58 grams of PLA. Well, let me try to do it on the Dremel. Maybe it will go faster on the Dremel, just to make a test on it. 200. This is from, make 4 layers. 4 layers. 25. No supports. Infill, retin area. I want a grid. Temperature 205. Cooling, G-code. Cooling, we do only 50% in the beginning on the first layer, and then we give it 100% on the second layer. Script is okay. Speed 25. That's very low. It was my first layer, so I give it 50 as well. movement speed, quite fast. On the advanced, look good. And center and range, it can obviously almost be there. It can. Let's see. And 4 hours and 10 minutes. So I want to use my Ender 4, and it's mainly because I have a heated bed on this one. I want it really to be plain on the top. So let's go into this and do the Ender 4 settings. Again, we use 15 minutes more, and that's mainly because of the travel speed. So that is our thing. It looks quite good. It doesn't seem to any errors. It's also a simple construction, but here you see the grid, and I could maybe save a layer on the top, maybe also in the bottom. Let's try to look on the process and see what's going on there. Here we go. And we do like that and prepare again. Well, we got down to 4 hours because of that. So that's great. That we do, 4 hours, and well, then I will go and prepare the printer and start to print. So see you at the printer. So we have now printed the flange, and it looks quite good. I have tried to sand blow it a little bit, and I will show that in another video, but it seems it works in some cases. Anyway, our flange is finished printed, and I modified it a little bit, especially on the infill, and I also put the speed up on, I think it was 60 millimeters per second, and I put an infill on 15%, and it works very well. And that reduced the print time to, I think it was around 3 hours. So this was a pipe from my house in Thailand, and this will fit exactly on the top like this. So when this comes up from the floor, and I have my wash like here, and I can now turn the flange so it fits in the other bathrooms as well. As you can see, the hole are now moving into different positions compared to if it has been in the center. So what I will do when I come down there, I will use silicone before I press it down. I will put the flexible pipe, that's hose, into the hole here, and also give that a little bit silicone, and I should be quit all the bad smell I have there. So thank you for watching. If you still are here, it was quite a long video, so thank you for that, and see you another day, another time. Have a happy printing. Bye bye.